What's with the homework on air conditioning? You aren't by any chance planning on doing me out of my job, are you?
No, not at all, Jack. For the present, I'm satisfied with the bump and grind routine back in the body shop. But I guess you're right in calling this homework. You see, that kid of mine, Artie, thinks I'm the greatest authority in automobiles since Walter P. himself. And last night, he started asking me a lot of questions about air conditioning that I couldn't answer. Oh, I have a general idea how the basic refrigeration system works. But when Artie started asking me about differences between Dart's, Fury's, Charger's, and Imperial's air conditioning systems, I was in over my head.
I think Jack and I can give you a quick refresher on air conditioning that will help you keep your image untarnished at home. We'll even give you a rundown on the latest production changes and explain how these changes affect service.
You already said you understand how a basic refrigeration system works, and this is the same on all of our air-conditioned cars. However, minimum evaporator temperature control, air distribution, and discharge air temperature control are not the same on all models. For example, let's start with evaporator temperature control on our compacts. On these models, the refrigeration system is cycled or turned off and on by disengaging and engaging the compressor clutch.
If you want cool, why not run the refrigeration full blast?
If the refrigeration system ran at the maximum cooling rate, the evaporator temperature could drop low enough to freeze the moisture in the air. Frost would form on the evaporator, and under extreme conditions, this would clog the fins and restrict airflow. On our compact models, an electric thermal switch having a sensing bulb inserted between the evaporator fins senses the temperature. This switch is connected in series into the compressor clutch circuit.
Before the evaporator gets cold enough to cause frosting, the thermal switch opens, shutting off current to the magnetic compressor clutch. When the evaporator warms up a bit, the switch closes, and the clutch engages to restart the refrigeration cycle.
The temperature range of the thermal switch is adjustable, Art. There is a mechanical connection between the temperature control lever and the thermal switch. As the temperature control lever is moved to the right, the thermal switch is adjusted so that it operates at a higher temperature range. The evaporator doesn't get as cold, and cooling is reduced.
What do the Max AC and AC buttons do?
Well, when the Max AC button is pushed, the vacuum actuator system closes the outside air door and opens the recirculating door. Since no hot outside air is introduced, only cooler inside air, maximum cooling is provided. Incidentally, the Max AC and the AC buttons also control the electrical input to the thermal switch and the compressor clutch circuit. In other words, the only time the clutch circuit is activated is when one of the AC buttons is pushed.
Well, I get that, but how about the heat and defrost buttons?
The heat and defrost buttons do several things. Pushing either of these buttons opens the water valve. Opening the valve lets coolant flow through the heater core. The heat and defrost buttons also control a vacuum actuator system for the heat defrost door. When the heat button is pushed, vacuum positions the heat defrost door so that some air is directed upward to the defroster outlets and windshield. Most of the air is directed downward to the heat duct outlets. When the defrost button is pushed, most of the air is directed upward to the windshield, and a much smaller amount is directed to the heat outlets.
How is air temperature controlled?
For heat and defrost, air temperature is controlled by a blend air door. The position of the door determines how much outside air is directed through the heater core and how much bypasses the core. Here's how that's done. The temperature control lever is connected to the blend air door. When the lever is moved toward the left, the blend air door allows a large amount of air to bypass the heater core and directs a small amount of air through the heater core. As a result, less heat is delivered to the car interior. Of course, in the no-heat position, all air bypasses the heater core. As the temperature control lever is moved to the right, the blend air door is positioned so that much less air bypasses the heater core and much more air is directed through the heater core. In the full heat position, all air passes through the heater core. Incidentally, both the air conditioning thermal switch and the temperature control cable are connected to the blend air door linkage. However, this doesn't affect heating because the clutch isn't engaged unless an air conditioning button is pushed. And the blend air door doesn't affect air conditioning because there's no heat in the heater core unless a heat or defrost button is pushed.
I think I have the compact set up straight. The heater air conditioning system operates either as a cooling system or a heating system, but the two are actually independent of each other. The refrigeration system is cycled by engaging and disengaging the compressor clutch. The thermal switch actually controls clutch cycling so that the evaporator won't frost up. Since the thermal switch operating range is adjustable, it determines the temperature of the air delivered to the car interior. On either heat or defrost, the water valve is always fully opened. Discharge air temperature is controlled by the blend air door, which determines how much air bypasses the heater core and how much is sent through the heater core.
You've got the story straight, Art. So now we'll explain how the air conditioning system for the intermediates is different. On Satellite, Charger, Coronet, Barracuda, and Challenger models, the clutch is engaged and the compressor runs continuously on AC and max AC. Minimum evaporator temperature is controlled by regulating evaporator pressure.
How is that done?
There's a direct relationship between evaporator pressure and evaporator temperature. As the evaporator gets colder, the pressure of the refrigerant gas leaving the evaporator gets lower. You can regulate evaporator temperature by regulating the minimum pressure of the refrigerant leaving the evaporator. Evaporator pressure is regulated by a modulating valve located in the suction or inlet side of the compressor. This is called an evaporator pressure regulator, or EPR valve. It is pressure sensitive, and its operation is completely automatic. As the evaporator temperature approaches the frosting point, refrigerant pressure is reduced, and the EPR valve begins to close. It never closes completely, just enough to modulate refrigerant flow and slow down the cooling process so that moisture on the evaporator will not freeze. This system also functions as a dehumidifier. The incoming air passes through the evaporator fins, where it is cooled to the lowest possible temperature, short of freezing. This wrings out excess moisture. This dried air is then sent through the heater core and warmed, providing there's hot water in the heater core.
This method of controlling temperature is referred to as the reheat principle.
How is heater core temperature controlled?
The temperature control lever is connected to a water valve. The water valve varies the amount of water flowing through the heater core. This water valve is a combination bypass and flow control valve. When the flow valve is closed, by moving the temperature control lever to the left, the pressure opens the bypass valve and coolant returns to the engine without flowing through the heater core. Moving the temperature control to the right opens the flow valve. Coolant flows through the heater core before it returns to the engine. The position of the bypass valve depends on engine speed and coolant pressure.
I see how that works. Now tell me, what changes when max AC is selected?
The control system positions an air door so that it shuts off all outside air and provides recirculation of inside air. Soon the car interior is cooler than outside air, so recirculating the air provides maximum cooling. Temperature control and air distribution is the same when AC is selected.
And that brings us to heat and defrost. For either of these, the compressor clutch is not engaged, so there's no cooling. Airflow through the evaporator and heater core is the same as for cooling. Temperature is controlled by the water valve, just as it is for cooling. However, air is now delivered through the defroster and heater outlets. No air is delivered from the air conditioning outlets. For example, in the heat position, some air is delivered to the windshield for defrosting, but more air is sent to the low-level heat outlets. On defrost, there's more defrost air, less heat outlet air.
Now let's see if I have the facts straight on intermediates. The EPR valve, and not the clutch, controls the refrigeration system to keep the evaporator from getting too cold and frosting up. On both max AC and AC, this system operates on the reheat principle. The air is cooled to get rid of the moisture and then reheated. For both heating and cooling, the water flow valve controls coolant flow through the heater core, and this determines the temperature of the air delivered to the car interior.
Right on, Art. Now turn the record and find out about the system used on full-size cars.
There are some significant differences between the system used on full-size cars and the one used on intermediates. However, these two systems also have a lot in common. For example, both the intermediates and full-size cars use an EPR valve to regulate minimum evaporator temperature. As a matter of fact, the EPR valves are the same for both systems. Unlike the intermediates, the clutch is always engaged and the compressor operating when the engine is running, even when the off button is pushed.
Well, how come?
That's a good question, and it calls for a bit of explaining. To begin with, although this system also operates on the reheat principle, the airflow and the arrangement of the blower, evaporator, and heater core is entirely different. The blower is located at the far right side of the car and pushes the air through the system. Flow is through the evaporator, where the air is cooled and dehumidified, then through the heater core before being distributed to the car interior.
Well, how about temperature control?
The temperature control lever is connected to the water valve, which regulates the flow of coolant through the heater core. This part of the system, including the combination bypass and flow valve, is just like the intermediates. Notice that the evaporator and the heater core are very close together and back to back. Well, as a result, if moisture has collected on the evaporator fins, it may be blown onto the heater core. If the heater core is warm, this moisture will evaporate rapidly, and humid air will be blown onto the windshield when the heat or defrost button is pushed. If the windshield is colder than the humid air, moisture will condense out on the cool glass. Several things have been done to minimize this condition. Incidentally, on intermediate models, the heater core and the evaporator are separated. The blower pulls air through the evaporator and then blows it through the heater core. This arrangement virtually eliminates the likelihood of moisture from the evaporator being blown onto the heater core. On past model full-size cars, a time delay relay was added to the compressor clutch circuit. This relay engages the clutch for as long as 10 minutes when either the heat or defrost button is pushed. The evaporator cools quickly, dehumidifying the air. Drying the air before it is delivered to the windshield minimizes the possibility of moisture condensing on the cool glass. As an added precaution, an orifice in the vacuum system delays the opening of the defroster door. As a result, when the heat or defrost button is pushed, the first blast of air is delivered from the air conditioning outlets instead of the defroster outlets. This further reduces the problem of condensation on the windshield. Beginning with the 1972 models, the push-button assembly was redesigned so that the compressor clutch is engaged even in the off position. As a result, the evaporator is cold, and this provides maximum drying of the air and minimizes the condensation of moisture on the windshield.
Doesn't running the compressor all the time waste a lot of power and gasoline?
No, Art. As a matter of fact, it takes very little power to run the compressor when the heat load on the evaporator is light. So increase in fuel consumption is very slight. Consider the facts. When the off button is pushed, it's because outside temperatures are moderate and you don't need heat or cooling. The evaporator cools down quickly, and the EPR valve takes over to control the system. Under this condition, it takes very little power to run the compressor. When the heat or defrost button is pushed, it's because the outside air is cool. Under this condition, the heat load on the evaporator is even less, so very little power is required to run the compressor. In fact, when either heat or defrost is selected, moving the temperature selector lever approximately 1/4 of its travel to the right opens a switch in the clutch circuit and stops the compressor.
Well, that answers my question about the compressor running continuously. Now, what's the story on the blower running all the time, even when the off button is pushed?
A lot of owners have asked the same question, and I'm afraid some of them got no answer, or maybe the wrong answer. Now, here's the straight story. Since it is virtually impossible to make a car airtight, it is generally considered desirable to pressurize the interior so that all air leaks will be from the inside out rather than from outside in. At the beginning of the 1972 model year, two things were done to provide a positive pressure inside of the full-size cars. A bracket was added to the opening for the outside air door so that the door would not close all of the way. With this opening to the outside, Ram Air maintains a positive pressure inside the car under highway driving conditions. To ensure a positive pressure condition at low speeds or when standing still, a blower circuit, which bypasses the blower speed control switch, was added. This circuit is connected into the ignition so that the blower runs at very low speed whenever the ignition is turned on.
Because the message on pressurizing the interior wasn't getting through to customers, both the outside air door bracket and low blower speed bypass circuit were eliminated in later production. If a customer wants to pressurize the interior, he can push one of the heat or cool buttons to turn the blower on.
This shows the original brown wire and tan wire connections at the blower circuit resistor block. If the owner of an early production car insists on eliminating blower operation in the off position, the modification is easily made. This shows the field modification. The connector at the blower circuit resistor block has been removed, turned 180 degrees and reinstalled, so that the tan wire is reconnected to the same terminal, but the brown wire is now disconnected. In addition, the exposed brown wire terminal must be insulated to prevent accidental shorts. This is easily done by slipping a piece of rubber or plastic hose over the terminal.
Is there a field modification for the bracket on the outside air door?
There's no need to modify the air door, Art. No one has objected to the small amount of air delivered after the car is on the highway and moving fast enough to provide ram air. The only objection has been to that first cold breeze delivered by the blower bypass circuit when the ignition is turned on. While we're on the subject of modifications, why don't we tell Art about the changes that have been made to eliminate evaporator housing leaks on full-size cars?
Good idea, Tech. On early production cars, the front and rear halves of the evaporator housing were fastened together by screws and J-nuts. If these screws are loose, moisture which is condensed out on the evaporator will drip down on the front compartment carpet. So the first cure for such a leak is to tighten the screws. Do not over-tighten them or you'll crack the evaporator housing. If tightening the evaporator housing screws does not correct the leak, it may be necessary to reposition or replace the evaporator housing seal. However, very small leaks which persist after tightening the screws can often be corrected by applying a mastic sealer to the evaporator housing joint. In current production, the screws have been replaced by spring clamps, which literally squeeze the two halves of the housing together. This has virtually eliminated the condensate leak problem. Incidentally, when the spring clamps entered production, the screw holes were not eliminated from the housing, so when you see one of the late jobs with clamps, don't think someone forgot the screws. They simply aren't needed.
Just to make the story of 1972 air conditioning systems complete, we should mention AutoTemp, the automatic temperature control system.
AutoTemp air conditioning and air distribution system is basically the same as the standard air conditioning system for full-size cars, except that temperature is controlled automatically for heating as well as cooling. In addition, the method of controlling evaporator temperature is different. In the AutoTemp system, the evaporator pressure regulator valve has been replaced by an evaporator temperature regulator valve. Both valves accomplish the same thing. They control the refrigerant flow so that the evaporator won't get too cold and frost up. In operation, there is one minor difference. The EPR, the evaporator pressure regulator valve, modulates refrigerant flow but never stops it completely. The ETR, evaporator temperature regulator valve, is normally fully open. It is closed by a solenoid built into the valve. Frost control starts with a thermal switch mounted on the evaporator housing. This is an electric switch having a temperature-sensing capillary tube inserted into the fins of the evaporator. The thermal switch contacts close when the evaporator temperature approaches the frost point. This energizes the ETR valve solenoid and restricts refrigerant flow.
I sure came to the right place to learn about the differences between our various air conditioning systems. I want to thank both of you.
Just to make sure you don't forget any of the facts we've covered, here's a copy of this month's reference book. I'm sure it'll answer any questions you and Artie have on the differences between our air conditioning systems. And of course, you men out there will get your own copies of the reference book. Whether or not you work on air conditioning, I'm sure you'll find the information interesting and useful. We'll see you all next month with a timely session on roadability and handling.